Hi, this is Jenny Baldwin, and I am the Elementary Math Instructional Coach. And today I'm going to go over the 4th grade Math Plus Red Unit 3, which focuses on applications of operations. This unit has 11 lessons, which is not quite as long as Unit 2. Unit 2 focused on a lot of strategies in order to multiply and divide, and now we are going to apply some of those same strategies. Lessons 1 and 2 focus on the order of operations, and I will say that these two lessons are a little bit more of an enrichment opportunity because this is a 5th grade standard, or students will be assessed on it in 5th grade. It definitely is appropriate for students to begin practicing and thinking about how the answer changes when the order of the operations change and why we might need to group certain numbers together in a certain way. We're then going to talk about the distributive property and then move into word problems where we solve and check our answers using inverse operations. And these lessons right here are the most critical components of the entire unit. So let's head on over to the Math Plus Red activity book. And remember that if the side tab is closed, you can open it up and go straight to application of operations. And from here, this gives examples to students on why the order matters and how grouping symbols matter. The digits are still the same. We have a 7, 3, 6, and 2, but by adding the parentheses and doing that part first and then doing the other steps, we get a totally different answer every single time. So this is important for students to understand. Now, I am going to share with you a document that is also in the newsletter called Reflecting on PEMDAS. PEMDAS is basically a shortened acronym for the orders of operations. It means parentheses, then exponents, multiply, divide, add, subtract. But some people have even called PEMDAS a problem, like we have the problem with PEMDAS, because students automatically want to follow this in exactly this order. But unfortunately, that is not what PEMDAS stands for. You may have also heard, please excuse my dear Aunt Sally, as a way to follow the order of operations. But we forget, and we often teach students the wrong way when we follow this exactly. The multiply and divide need to come in order whichever comes first, and the addition and subtraction needs to come in which order comes first. And I'm going to turn on my webcam just to share this with you a little bit more and so you can see a better strategy. But I do encourage you to read that article so that you'll understand the misconceptions that students often have, because if we teach them the wrong way, they're going to remember it the wrong way. And this is a critical skill, especially as they progress through middle school. I often like to think of it as like a hopscotch board. We definitely want to do things that are in parentheses or brackets first. Then from there, we build up and do our exponents. Now, in 4th grade, we're not going to even use that step, but we can always encourage students to know that there is a step, even though we're not seeing it. Then, when it gets to the next step, multiply and divide, it's whichever comes first. It doesn't matter if the division's here or the multiplication's here. It's whichever comes first from left to right. And then the same thing is true with addition and subtraction. Whichever comes first from left to right. So instead of just writing, please excuse my dear Aunt Sally or PEMDAS, I always encourage the symbols, and you might even want to block off the numbers and draw a square around them, or the letters and draw a square around them, so that students remember that if you have a problem, and let's say we have 4, take away 4 minus 2 divided by 2 times 3. So let's see what we have. The first thing we're going to do is, and I would always encourage your students to do this too, we want to do the parentheses. So we're going to underline that part and we're going to write everything else. And again, this is enrichment. Your child will not see something like this on the end of the year assessment. It is in the OLS, and you can work with your child and talk to them about it. You don't need to expect mastery, but I think it is great to work with them and introduce them to these concepts. So we keep this 4, we take away 2. Then we divide by 2 times 3. Now, if we followed multiply before divide, we would do this first and it would totally mess up our answer. We need to do whatever comes first from left to right. We don't have any more parentheses, we don't have any exponents, so we are going to divide. So we have 4 minus, and I know 2 divided by 2 is 1, times 3. Now, I know that multiplication always becomes before addition and subtraction, so I will multiply, and I have 4 minus 3, and my answer is now 1. So it's important to teach that we don't just follow PEMDAS, we do parentheses, then exponents, multiply, divide, whatever comes first from left to right, add and subtract whatever comes first from left to right. So please take the time to read this article because I think you'll find it very beneficial, and it's going to apply to everything they do in math from here on out through 5th grade, middle school, and high school, and even college. So let's go back to the OLS and to the activity guide. There's going to be continuous problems that say, place the parentheses so that this expression is true. I will tell you that this is a question that I saw on the 5th grade CRCT. It is not something that's going to be on the 5th grade or 4th grade Georgia Milestones, but remembering that this is important is something to think about for the future, because we do want students to understand that placement of parentheses is a critical component to getting the correct answer. More importantly, we want students to know why the order of operations even works. We need to apply these not just in a string of numbers, but to really apply them in word problems, and we'll talk about that in just a little bit so you can see exactly what I'm talking about, and helping students make sense of what this is even all about. It's not just about following rules and procedures, it's really about understanding why something works. Here are some great problem-solving activities as well, but they do focus on just more answer getting. But the part that is very critical is this explain why or why not. It says Dallas got the same value for these two expressions. Is he correct? Explain why or why not. And as I've mentioned, I think the problem with some of these lessons is that students are going to automatically answer simply, they didn't follow the orders of operations without really thinking about what it means. And basically, this problem right here means something totally different than this problem right here. If we had 8 times 3 plus 9, and we thought of it in a word problem, we might say there are 8 children, and they each had 3 chocolate chip cookies and 9 sugar cookies. How many cookies did they have in all? So we could add up, well, each child had 3 chocolate chip and 9 sugar cookies, so when you add them all up, that's 12. So we have 8 times 12. Here, we would have 8 times 3, which would be 24 plus 9 more, and we would get a totally different answer. So it does matter how we put those parentheses, and it does matter, or the order of operations truly does matter. We're next going to get into the distributive property. And the distributive property is something that your student should have seen in 3rd grade. And I'm going to use my document camera again just to show you some blocks. And this is something that's fun to do even with cereal or Cheez-It crackers or blocks in your own home. But we can see that we have 3 rows, and we can see if we look at this entire piece here, we see that there's 5 in each row. But what if I broke this apart? And what if I drew a line right down the middle? I still have 5, but I could break it up into 3 and 3 and 3 and 2. So we could write this equation to show that we have 3 times 3 plus 2, because I know 3 plus 2 is the same as 5. Or I could work it out and say, and so there's a couple ways I could work it out. I could say 3 times 3 and do this part first, this first part right here. Say 3 times 3 is 9, and then 3 times 2 is 6. So 3 plus 6, and I would get 15. Or I could add the parentheses first and say 3 times 5. I know 3 times 5 equals 15. So either way, I get 15. So we want students to understand that when we do put parentheses around something like that, that we're technically multiplying the 3 times the 3 and the 3 times the 2, or we could just add them together and then multiply. Sometimes when there's larger numbers, they're going to want to multiply times two smaller digits instead of larger numbers. So the distributive property is important, and it is something that they may see, and we just want them to understand what this means so they can check and see if the expressions are correct, and then try to rewrite them in a different order. After we go through the distributive property, the students are going to begin to work on the story problems, and they're going to learn how to solve and check their answers. Like I said, this is one of the most critical components because we want students to be able to read a problem, know whether they have to add, subtract, multiply, and divide, and then we want them to be able to check their work by using the inverse operation. So the opposite of multiplication is division, the opposite of addition is subtraction, so they can use that inverse to check. Here we have identified the operation. I will show you, and I'm going to put this link in the website as well, that when we want students to identify the operation, we definitely want to be wary of using keywords or having students, oh, just go circle the keyword and it's going to tell you what to do, add, subtract, multiply, divide. But I'll show you right here as an example of a problem. It says there are 76 tiles per box and I bought 38 boxes. How many tiles do I have altogether? A lot of students automatically circle that word altogether and they think altogether it means I'm going to add, so I'm going to add 76 plus 38 to get my answer. Unfortunately, that's not what the question asked. If we have 76 tiles in every box and we have 38 boxes, we need 76 38 times and we need to multiply. So we want students to make sense of the word problems, not just circle a keyword. There are great videos in this link that I'm going to share with you that has examples of students who do come across typical misconceptions because of the wording in a problem, and there's some more examples. And some of them are success stories and some of them are not, but they're great for us to be aware of so that we make sure we're teaching math the right way. There are lots of problems in practice for solving and checking work using the inverse, and we will get also into two-step problems that require students to maybe perform addition and subtraction or multiplication and addition all in the same problem. We want students to be able to analyze the work of others. This is the type of problem that they might see on the end of the year assessment. Right here it says say yes if the solution is correct and no if the solution is incorrect. And they need to determine what operation to use and then how to check this answer. One of the components of the math standards state that students will be able to use tools to get the right answer. They will be able to argue their answer. They will be able to be precise and check their work. And they will be able to question the reasoning of others and state why their reasoning is correct. So here it says that each year the local town hosts a music and art festival. Last year there were 935,000 people at the festival. This year there's 17,000 more people attended the festival. How many people attended the festival this year? So let's add these together, and they were able to get 952. Is that answer correct? Well, let's use, if we add to get this, let's use the inverse or opposite and subtract. So we could take this number, subtract 17,000, and see if we do get 935,000. So we can check our answers, and that's what we want to encourage students to do. Not just get an answer, we want them to prove that their answer is correct by using the inverse operations. On the end of the year assessment, students who take time to use their scratch paper and actually check their work do so much better just because they are using that time to really think about it and make sense of the math. As we continue to go through, you're going to have more story problems and more opportunities to critique the work of others and choose whether the answer is correct and explain how you know. And then as we get to the core focus problems, it is going to be more of that type of modeling, and I'm going to get my document camera to work out this very first one because it kind of uses the order of operations along with the problem solving and applying the problems. So first of all, let's read the problem. It says Karine wants to make some floral baskets. 6 floral baskets will each have 14 red roses and 10 white roses. 2 floral baskets will each have 12 pink carnations and 8 white carnations. Karine wants to know how many flowers she needs in all. Write an equation to model the problem. Use a letter to represent the unknown amount. Now, what I would recommend on something like this, and I'm going to move this up, but I'm going to do one part at a time. We have 6 baskets, and each of those baskets, those 6, has 14 red and 10 white roses. So this is where we can really show what the order of operations, how we could apply that into a word problem. Because we have 6 baskets and each basket has this many flowers. We need to add those together. Then the next part says there's 2 baskets and each of those baskets has 12 pink and 8 white carnations. So 12 pink plus 8 white. Now, I know that the question said to write one equation, and you could put a plus sign and add this equation to this one. I personally think it's better to maybe keep them separated and add it together at the end. Now, if we follow the rules and we do our order of operations, and we definitely want to remember these go together, we're going to do the parentheses first. And I know that 12 plus 8 is 20. Now, it also says to use a variable to show the unknown. We don't know the total, and we're going to add those together to get the final total. So here I'm going to have 2 times 20 because I know 8 more than 12 is 20 equals the unknown amount. So then I have 20 2 times. 20 plus 20 is 40, or I could say I know I have 2 times 2 tens, so I have 4 tens, 4 groups of 10. So in this problem, the answer would be 40. So 40 is the X. Now let's work out this one, and I'll go over this direction. Now, if I add these together, it gets to be a larger number, such as 24. So if I have 6 times 24, that's not something as easy as 6 or 2 times 20. But I can make it an easier problem. I could have done 6 times 10 first, and then I could have decomposed this into 10 and 4, so I could have done that. I'm going to show you how you can still take this large number and break it apart, because I know that 20 is the same as 20 plus 4. So I can multiply. Instead of having 14 and 10, I can just rearrange those 10s and I still have 2 groups of 10 and a 4. So all I did was rearrange and regroup those numbers to make it a little simpler to add and multiply. I know that 6 times 20 would be 6 groups of 20. We have 18 tens, or 180. Or 120, sorry. We have 12 tens, or 120. And then we want to add that to 4 groups of 6, or 24. So this top amount with roses would be 144. When I have my 2 answers, I just simply add them together. 144 plus 40 is 184. So when the question says, Write an equation to model the problem. Use a letter to represent the unknown amount. We did that. How many flowers does she need in all? And we have 184. And when it says explain how you know, we want to say that we have 6 groups or 6 baskets of roses, and we could explain that 14 plus 10 is 24, and 6 times 24 is 144, and that we have 2 baskets of carnations, and 12 plus 8 is 20, 2 times 20 is 40, and 144 plus 40 equals 184. So using words, using models, breaking apart the numbers, applying the operations is what this unit is all about. I'm going to also show you the extended response portion of this unit. There are bigger numbers, and so drawing the models is key. This says there's 13 rows with 15 in each row, or a student may have mastered multiplication and using some of the strategies they learned in chapter 2 or unit 2, but basically they're saying, is this enough for her to plant all of the trees? We have 126 pine tree saplings and 74 blue spruce saplings. So if she has a field with 13 rows and 15 trees, is that enough to plant all of these trees? Explain how you know. There's also opportunities to divide and use your work to check. We have 2,161 miles divided by 8, and I'm going to pull out my document camera again, and I'm going to write this problem so that you can remember that it's not about the standard algorithm. So we have 2,161 divided by 8. We want students to relate multiplication to division. So when they see a problem like this, they need to think, okay, I know that 8 times 100 would be 800. That's definitely smaller than this. 8 times 200, or 8 2 times, would be 1600. That's definitely closer. So let's multiply 8 times 200 to get 1600, or 1600. And let's take away that one chunk for now. So we'll take away that, and we'll subtract. 1 minus 0 is 1. 6 minus 0 is 6. I can't take away 600s from 100, so I'm going to borrow a group of 1,000, or I'm going to regroup. We're not borrowing, because if we borrow, we would give it back, and we're not giving it back. We regrouped it and moved it over here. So now we have 1100s instead of just 100. We brought a whole nother group. We brought 1,000 over to make 1100s, or 1,100. So we have 1100s minus 600 is 500. So now this number has gotten much smaller. I've already taken away 200 groups of 8. So let's see how many more groups of 8 I can take away. I know that 8 times 7 is 56, and 8 times 7D would be 56 tens. So let's take away 560, and I end up with 1 left over. Now when I add my parts together, I have 270 with a remainder of 1. I can then check my work, and I can say, okay, let's see, what 270 times 8. And I'm going to multiply 8 times 0 to get 8, 8 times 70 to get 560, or 56 tens. I'm going to have to carry my hundreds over to the hundreds. We have 8 times 2 is 16, plus 5 more would be 17, 18, 19, 20, 21. Okay, so my answer is very close. I have 2,160. Remember, we had 1 left over, a remainder of 1. So when I add my 1, I was able to check my work, and I got the same exact answer. So we want students to solve and check. There are more problems similar to that, and then this is one of my favorites. It says write a 2-step story problem that matches the number sentence. So have your child think about these numbers, and I thought about going to the apple orchard. So we could say that we picked 14 red apples and 13 green apples. How many apples did we pick in all? so they could get that answer. And then we could say when we got home, we divided the apples by myself, mom, and dad. So that would be 3 people. How many apples did each person get? So we have 27 divided by 3. And then we can estimate and show how we know our answer makes sense. So this is a fun unit. Part of it is enrichment, but it all lays the foundation for further learning. I hope you enjoy it, and remember that it is perfectly acceptable for you to focus or sit down with your child and help them understand the purpose of the order of operations. This is not something that has to be mastered this year, but it is something that will help them in years to come. Another thing that you can use to help students with word problems are thinking blocks. This is a free online program. You can also download this type of program onto an iPad. You can search the apps for thinking blocks, but it lets students really visualize the total and the parts that it must take to get the total. And also, just don't forget about the problems with keywords, and also problems when it comes to thinking about PEMDAS or the order of operations. We don't want students just to follow a list of rules. We want students to understand the math. And the one last thing that I want to talk to you about is the lesson guide. If you're ever having trouble finding the resources, make sure that you open up that side tab and go to the extended problem section and then the extended problem answer key. There will be times, and the teachers have skipped these units, when, for instance, in Unit 2, if you went to this section, you're not going to find the answers and the extended reasoning, because that is part of our portfolio grade for the year. So you won't necessarily find it here, but you can always ask your homeroom teacher where those resources are located. Thank you so much for joining me today, and I hope you enjoy exploring Unit 3. Next, we're going to focus on lines, angles, and rotation, and measurement is another big 4th grade skill, and it's fun to use a protractor and really design and apply our knowledge of angles to different shapes. Thanks, and have a great day.